newcomers, welcome, and the returning folk, welcome back. There's no need to have seen any of the previous sessions. It's a bit of a carousel. We try and, while we show new things each time, they're essentially independent from the last time. So it's you can just jump on when you're ready. Pretend you're around a campfire and we're just sitting, chatting, pointing up at the sky, and doing a little bit of storytelling to help you familiarize yourself with the sky and its patterns. And each time we also talk a little bit about features on the moon and some of the deep sky objects that are out there. We'll talk about things that move in the sky, moonrises, sunrises, and how they flow across the sky and during the year. I won't explain what you're seeing in front of you right now, because that in itself is just about a 15-minute exposition, but you can get some really cool things just very quickly. On the left here, these are sunrises once a month in Edmonton, taken from the same location. And it rises in the southeast in winter, in the east in spring, far to the northeast in summer, and then back again. So our original plan was to meet at the Queen Elizabeth Planetarium, shown here, just outside of the current TELUS World of Science. Hopefully, maybe this autumn we'll be able to get back to actually doing this in person. We'll talk a bit, step outside and point up at the real sky. We'll have a small telescope there. You could bring your own scope, and if you're having trouble using it, we'll give you a few pointers. First and foremost, these sessions are all about viewing the sky with your eyes. We have great monthly talks at our main meeting about black holes and galaxy formation and all that kind of real spiffy stuff, but this really concentrates on what can you see with your eyes in the sky, and that is a comet, lower right. So the thing that I like to emphasize a lot is just get outside and look up. It really makes a difference even if you're out there for 5 minutes, just to refamiliarize with yourself what the stars are. Ah, yes, that one's Vega, that one's Altair, and so on. And it very quickly becomes second nature, and the patterns sort of fall into place. And we're here basically from the Royal Astronomical Society of Canada, RASC for short. And we've kind of designed these sessions to work alongside the Explore the Universe program. And even for non-members and members alike, if you complete the program, you'll get a free pin and certificate. So what I urge you to do is get onto the web page. There's a link for the Zoom session here, and there's a link to the print at home workbook for the Explore the Universe certificate, and follow along. There's 10 pages or so of places where you can put in notes. And again, there's no start or finish. It's just we begin where we are tonight, and in a year's time, you'll just about be ready to submit your notes to get the certificate and pin. This is a couple of samples from it. It outlines some of the constellations and bright stars that you need to be able to identify to earn the certificate, and we do this. I'll be doing it in under 5 minutes. We'll be starting that. Things like how to observe the moon as well. And so it's very, very simple. Name your deep sky object, but date, time, and what you did, whether you use your eyes or binoculars, and a place for writing notes. Just a little blurb about who the Royal Astronomical Society of Canada is. We're some 5,000 people across the country. There are a few professors from universities floating in our membership, but the vast majority of us are ordinary amateurs from every walk of life, from doctor and lawyer down to carpet cleaners to retired folk to people earning a minimum wage. It doesn't matter. You just need to be able to use your eyes and look up at the sky. And so actually there's another certificate, Explore the Moon, and Berta actually does a little bit of that in these sessions here. You can even start learning how to do astro images on your smartphone if you have no other equipment. So it's no problem about starting anywhere. And then finally, why become a member? There's wonderful people, as I would like to say, made some lifetime friends as I've been a member. We do outreach. We have our monthly meetings. Jeff does his What's Up in the Sky this month. We mentor people. We had a question last Wednesday. Are there any mentors in Edmonton? Just like, well, probably. A third of our center members would you might be able to consider them to be a mentor. You just need to ask, and we're ready to help and give pointers. And so this is what we're about. That's my last one of that, and we'll move on to our proper session here. So hopefully that gave you a little bit of a context as to why we're doing this and the reason behind our choice of objects. Okay, so we're going to cover some satellite, the International Space Station, what we can see in the winter sky, a little bit about the moon, some deep sky objects, because shallow sky would be inside our planetary system, very close to our sun, and deep sky means the vast beyond. Then we'll end up with why is a day 12 hours? Why not 15? Why not 7? Also talk a little bit about the face of the moon. Right, the International Space Station travels about 400 kilometers above us in an orbit around the Earth. And it takes about 90 minutes to do a full circle, and sometimes you can see it 2 or 3 times in one evening session. It's very bright. It's probably the second or third brightest object in the sky behind brilliant planet Venus. And it crosses the sky about the same speed as apparent speed as a high-flying aircraft, as you would look up, but it's going a lot faster, and it's because it's a lot higher up. So when can we see that? I urge you to get a login for Heavens Above, and you can just do a couple of clicks. Of course, you have to say where you're observing from. It's Timbuktu is a little different sky than here in Edmonton, and it'll make this lovely list for you. And right now, it's not visible in the evening sky. It's visible in the morning sky, but it's a little too early for me at the moment. But in the evening sky, we can expect to start seeing some nice passes by mid-month in March. And you just sort of click on it, and lo and behold, a map shows up with the path laid out and little time markers. So you can see from here as it passes Sirius, it's at 8:33, 8:34, and it's passing Regulus at 8:35. So you can see it takes about 4 to 5 minutes to cross an entire large swath of sky. So you're not going to suddenly miss it. It doesn't whoosh across the sky. So we're going to start with the late winter sky here in Edmonton, and prominently featured across the south. That's why I put this big S here at the bottom of the chart. And you can print out this chart just by going to the web page for these Zoom sessions. And the middle of the chart is overhead. And if you actually sort of held up the sheet above you and craned your neck, this would be directly overhead, and the top of the chart would actually essentially be behind you. So high overhead, we've got the bright star Capella, and it's a really good idea to learn these names. We don't need to learn 800 names or anything like that, but a couple of dozen will suits really well, and it's really good for communicating with others about where you see things in the sky. So the great constellation of Orion, it actually looks like something nice. In this case, the Western concept is a warrior with a belt of these three almost bright stars, and they point down to the bright star Sirius, which is the brightest star in the entire sky. So no matter where you are on Earth, if you can find Sirius, there will not be another star that's as bright as that one. Last month, we covered a little bit about the shoulder Betelgeuse, the red giant in Bellatrix, its neighbor. And today we'll be talking about Procyon. Next month, we'll get on to Regulus. I think a couple of months ago, we talked about Castor and Pollux, the twins of Gemini. And this whole sort of big circle of bright stars is sometimes called the winter hexagon. Sometimes it's a capital letter G ending in Betelgeuse. But just take this chart, go out sort of night after night, even if it's -20, you only have to stand outside for 3 or 4 minutes and just sort of look at the chart and go, okay, that one's Betelgeuse, that one's Sirius. And before you know it, you'll be remembering the names very easily. Okay, as I mentioned, Sirius is the brightest star in the sky. So here it is from a country sky. You can see the faint winter Milky Way, not as prominent as our summer Milky Way, but nonetheless, what is the Milky Way? It is our galaxy. Our sun is one of nearly 1 trillion stars, basically an impossibly large number to wrap your head around. And most of the stars in our galaxy lie in a flat disk. Think of it as a egg sunny side up, where the disk is the white part, and we live in the outskirts. And this particular view of the Milky Way is actually pointing away from the heart of the Milky Way and outwards. So here again, we have the wonderful constellation of Orion, the 3 belt stars pointing down to Sirius and almost pointing up to Aldebaran. Our feature star is Procyon from the Greek and Latin side of things, but for the Inuit, several of our Arctic dwellers call it Sikuliar Sujuyatuk. It's a tough one to wrap your tongue around for someone who's unfamiliar with Inuktitut. But it's a neat little story about a man who's much larger than the rest of the tribe. And it was because he's much larger, it was known that, well, he can't just wander out onto new ice, otherwise he'd fall through. And so the stories revolve around just this pair of a big man and his sister. And as with all cultural stories, it gets a lot more complicated and long, that's what long nights out on the sled will let you do. But for now, that'll be that. One of the interesting things that's tough to see about our sky is that it is three-dimensional, but we only see it as apparent flat dome above us. But in reality, the stars are at different distances to us. And it took a few centuries for scientists to figure out the distance scale and how you can tell whether one star is closer to us than another. And so it just turns out that Sirius is one of the closer stars to us, only 8 light years away. The very closest star to us, Alpha Centauri, which name ought to ring a bell, that's 4.3 light years away. So Sirius is twice the distance, 8.6 light years. And so part of the reason it's so bright is that it is actually pretty close to us. Procyon's not too much farther away, and it has about a mass of 50% more than our sun. So it is a bright star. It turns out, astronomers figured out that the heavier a star is, the more massive it is, the brighter it burns and the shorter its life. But in comparison, Rigel right here, one of the feet of Orion, it looks almost the same as Procyon, but it turns out it's considerably farther away, 800 light years compared to them. It's 100 times further away than Sirius. So you think, well, if it's that bright and it's 800 times away, it must be really, really, really bright. And it is. It turns out it's about 20 times the mass of our sun. So it's outpouring a whole lot of light. Okay, over to the moon, and we'll welcome Berta.
So hi, I'm Berta. Alistair and I together run this show, and so we are following. Alistair has explained that we kind of base this introduction into stargazing on the Explore the Universe program. So the first section of the Explore the Universe deals with the constellations, as Alistair has shown before. So that's what he has explained. And then the second section deals with the moon, and it requires you to observe the different phases of the moon and then to observe different features on the moon. So in Mare, which are the big darker areas, which are kind of like seas, but they're not seas. There is no water, but yeah, they're called Mare because they were thought to be seas. And then some of the craters in the moon are also part of the certificate. So today we are going to highlight one of these Mare, a lunar basin, which is Mare Nimbun, which is the translation means sea of clouds. This is one of the ones that you can, when you look at the moon around the 11th day of this cycle, and the cycle of the moon is the 0 day is the day of the new moon. And then after each day after new moon, you call the day 1, day 2, day 3 of the cycle until you reach full moon, which is in day 15 of the cycle. So around the day 11th, when the moon is getting close to being full moon, Mare Nimbun, the sea of clouds, gets it's near the terminator, it gets illuminated and is very clearly visible. This is one of the Mare that is at the bottom of the moon, down south, and you can see it more on the left side. It's around 720 kilometers across, and as I say, it's best observed when the moon is getting close to full moon, because that's when we start seeing that side of the moon. Thank you, Alistair. The next slide, please. And so then the certificate asks us to observe Mare, like the one that I mentioned before. And again, I would like to mention that these objects can be seen with binoculars. You don't need a telescope. Certainly the seas of the moon is something that you can completely see with binoculars because they are really big. And some of the big craters can also be seen with binoculars. And so the Explore the Moon certificate highlights the big craters. And so today we are going to talk about Clavius, which is one of the biggest craters that you can see again down south in the moon. Clavius is this very large crater encompassing several smaller craters. And if Alistair can please point it with the you can see it in there at the bottom of the moon, and you can see there is a big crater, but there are little ones inside. So that can also be seen to sort of guess or hint with binoculars. And craters are best seen when they are very close to the terminator, which is this side of the moon where you have the day side on one side and the night side on the other. And anything that is near the terminator has very strong shadows, and you can see the geography of it very well. You can see because the shadows make it see very clearly. So the best time to see a crater is when it's close to the terminator, and that for Clavius it happens between around the 9 and 10 days of the moon. So when it's 9 or 10 days old, that's and for example, what I've put here is the image of how the moon is going to be looking on Saturday, March 12th. That will be the 10th day of the cycle of the moon for the month of February and March. And so it will be around the weekend of March 12th is the best time to actually go and try to search for Clavius if you are interested in doing that. Thank you, Alistair. If you can continue to the next slide, please. Yeah, thank you. And so the next section in the Explore the Universe certificate is the deep sky objects, DSOs. As Alistair has said, those are the things that are far away from us, not like in our solar system, but farther away from our solar system. Sometimes they can even be farther away than our galaxy, but most of them are still within our galaxy. And so today we are going to highlight 2 of the DSOs that are listed in the Explore the Universe certificate for the winter section. Of course, the first one is the Orion Nebula N42, which is actually one of the most it's a great nebula. So it's like a cloud. Nebula comes from the word cloud in Latin, and that's how the earlier astronomers were calling anything that it was not a star and it was just a fuzzy patch in the sky. They would call it a nebula, like a little cloud. And so actually M42 looks like a cloud in the sky. We now know that it's actually a gas. It's a cloud of gas, but mainly hydrogen. But anyway, they didn't know that at that time, so they will just call it a nebula. And so it's the closest to us. And so it's the one that you don't need a telescope. You can see it with binoculars, and you completely make it. It's even better if you are in a dark sky, but you can see it clearly from the city too. And you will see a fuzzy patch in the sky. It's, as Alistair is pointing with the mouse, is located in the constellation Orion, which right now, if you look south, like Alistair has mentioned before, you look due south, Orion around this time of the night, 8 o'clock, 9 o'clock, it will be just there, and it's just halfway between the horizon and the zenith in the sky, and it's very easy to see. So the way to find Orion is that you look for the belt of, the way to find the Orion Nebula is that you look for the belt of Orion, the 3 stars that make the belt of the mythical figure Orion, and then you go down a little bit, and then you will find these two stars that are bright. And even by eyes, one of them looks fuzzy because the nebula is there. So you actually, even by eye, even without binoculars, you will see that that star looks a little bit fuzzy. And if you look at it with binoculars, you can actually start seeing the nebulosity around Orion, around that star. And then if you look at it with a telescope, you can see it even better. And so this is a great nebula, is the biggest one visible in the Northern Hemisphere. It appears as a bright cloud surrounding Theta 1 and Theta 2 Orionis, which are the stars that make the sword. And once you find M42, the Explore the Universe certificate suggests that you also look for the star cluster called NGC 1981, which is a little group of stars just on top of the nebulosity. That is shaped, the certificate says is shaped like an R, the back. I didn't know what was that. I had to Google it. It's a little kind of like little mammal that lives in Australia. So it's funny that they mention it here. But anyway, it looks like a little, I don't know, like a whistle or a skunk or something like that. So anyway, so Orion Nebula is something that we all, when we are learning, is the first object that we look at because it's just so easy to find and it's so marvelous to see. So I certainly recommend everyone to look at it. Alistair has a beautiful picture of it right now. So you can see the three stars that we have just mentioned that make the belt of Orion. Okay, and then if you continue down, you can see those ones that make the sword. And that star, even by eye, it looks a little bit fuzzy. Like you can see here in the picture, it doesn't really look like a star, it looks fuzzy. And if you look at it with binoculars, you can see this. And depending on your binoculars, I've seen, you know, my binoculars have a magnification of 9, and I've seen it pretty much, yes, like this, or even sometimes a little bit more clear, depending again of how dark is your sky. If you leave the city, there is bigger contrast between the nebula and the sky, and then you can see it more clearly. If you see it from the city, there is a little bit less contrast, and then you see it a little bit less clearly, but even from the city, you can see this nebula very well. Yes, and so Orion Nebula is actually a star nursery. Stars are being born right now. They're being created. They're being assembled, I guess, let's say, or I don't know how you want to put it together. They're being created in there. And so it's, again, a gas cloud, mainly hydrogen with other gases in there. And the force of gravity gets the gas together, and stars are formed over the period of course of thousands of years. And so I put two pictures in here, one that was taken in 1883, when this one of the early times of astrophotography. And I put it in there because this is kind of how it looks when you look at it through a telescope. You know, if you look at it with your eyes or a binoculars or telescope, it always looks just white over black, like a white fuzzy patch over a black sky. And so you can, and normally through a telescope, I don't see as much detail as you can see here in the picture. And of course, I had to put the picture taken by the Hubble telescope, and with a big caveat that this is not what you will ever see with a telescope or with binoculars. Our eyes don't see things in color in the sky. And so you need to take a picture to see the colors. But the colors correspond to different elements that are in there. And but you don't see it, you will never see it in color, no matter how good of a telescope you have. That's just a fact. You would just see it black and white.
A slight positive correction for that is in about a year's time, hopefully, fingers crossed, the Black Nugget Lake Observatory to the east of Edmonton that our center is currently building will house a 32-inch diameter telescope. So just a bit short of a meter across, it will pull in so much light that we will be able to start seeing sort of pastel color. It'll never be saturated reds or green, but there's actually a lot of green in this image. This area is white, and as probably most of you know, white light is combined colors of red, green, and blue. And to the eye, this area will be an emerald green in that large telescope. I am very much looking forward to that.
Okay, thank you for the correction, Alistair, and I'm certainly looking forward to that too. But yes, as of now, I've looked through several telescopes, the biggest one being a 16 inches, and I haven't seen any color. Other that if you use an oxygen filter to look at it, then it looks green, everything, but that's an artifact of the filter. Yeah, can we go to the next slide? And so from the Orion Nebula, which is spectacular, and certainly all of you will try to go and look for it because it's so easy to find, and it really, I think, is one of the things that get you hooked to astronomy because it's just one of these highlights of the sky. We are going to move to another item, which to me was a little bit more difficult to find. And actually, the first time that I saw this Campbells Cascade, which is a group of stars in the sky, I saw it because Alistair showed me how to look for it. So thank you, Alistair, again. when I looked when I tried to look it on my own, I could never find it. And then Alistair saw me, and then it was so easy, and it's really pretty. So Campbell's Cascade is a star chain. So it's just basically a group of stars that just by chance, there is no alignment, it's just by chance, they form a beautiful line of stars that look like a waterfall, kind of. The way to find them is that you have to start in Perseus, at least that's how it's shown in here. So you start in the constellation Perseus, which is easy to find this kind of yellowish star Alpha Persei, which is really bright. And then you have to scan 2 binocular fields. So like take the binoculars from one side to the other, you move 2 times until you see the stars moving from one side to the other with your binoculars towards Polaris, the star Polaris. And then you will see this long chain of stars, which resemble a waterfall. And this asterism is named after the late Father Lucian Campbell of the Rask Regina Center. So he was a person from here, from Canada, who sent a letter to some editor or something, explaining that he has seen this beautiful group of stars that make a very beautiful alignment. And so they name the group of stars after him. And then if you're looking with binoculars, you can find that at the end of the chain, and these are 2 images of the chain. The first one is one of the astronomy picture of the day. So if Alistair, you can so you can see this beautiful line of stars. And then at the end of the chain, almost at the bottom, you will see a star that looks a little bit more fuzzy because it's actually a star cluster. I don't think you can actually make it with binoculars. So you just see a star that looks a little bit more fuzzy. And to the right of the image, we have a picture taken by Alistair, if I'm correct, of this, again, this beautiful group of stars that has a brighter one in the middle, and then this fuzzy star at the end, at the tail of it. And so it's certainly not as impressive as the Orion Nebula, but it's a little bit harder to find too. So it can be a challenge. So it could be something that you can make an objective for yourself to try and find and observe this Campbell's Cascade. And to look at it, you actually have to look due north. So Orion Nebula is due south, so you have to look towards the south. But Campbell's Cascade, it's north in a very almost not known constellation by anyone, and maybe Alistair can name it because I cannot even name it.
Camelopardalis. The name is actually it's a giraffe, and you go, how do you get Camelopardalis into a giraffe? Well, back in the early days, they thought, oh, it's a camel that has leopard spots on it, so it's a cameleopard, so Camelopardalis.
Mm-hmm.
But one of our members once described it as, oh yeah, that's Latin for large empty space in the sky. There are really no bright stars anywhere around, but scan with binoculars and you find these gems.
So that's so it can be a challenge, to actually locate the part of the sky where this constellation is. And again, by eye, none of the stars that make the constellation can be seen by eye. And then look for the Campbells Cascade with binoculars, and you will find it. It's really pretty. So Camelopardalis just can be another challenge for someone to try and search. Okay, thank you. Can we go? And then it's your turn, Alistair.
Thank you.
I just want to say, normally I do talk about double stars because that's something that is also in the Explore the Universe certificate. But for winter, they only have 3 double stars in the list, and we already covered them in the previous sections. So next time we will talk about the double stars in the spring in our March meeting. Okay.
Okay, great. Thank you. So on to the segment where we talk a little bit about cycles in the sky and why we have various names and numbers floating around in our calendars. And so this evening, I'm going to talk a little bit about why 12 hours on a clock? Why not 15? Why not 7 or 11? And so that basically, there's 2 simple reasons. One is that there are 12 full moons in a year, so it makes sense to do that, one for each. Everybody likes symmetry. But there's another neat thing that happens with the number 12. It turns out, on one hand, if you use your thumb and touch your fingers, you can actually use your thumb and count from 1 to 12 on your fingers. So that was a very straightforward way of basic math and bartering for of humanity way back when. It's just like, well, if you can count to 12, yeah, you've got a hand, you can count to 12 and not get defrauded at the market. But as mentioned at the right there, 12 is also a special number in that it's very easy to divide into groups when you use the number 12. So the Babylonians preferred counting by 12s rather than by 5s and 10s, as most modern people like to do with just a hand or your fingers and toes. But the 12 splits apart really easily. Try and divide 10 into groups of 3 or groups of 4 and you're stuck. So having 12 there. So the number 12 sort of comes up a lot. So it makes a lot of sense that when they talked about, the first hour of the day, the second hour of the day, they just like, it makes sense to break the day time up into 12 segments. Okay, now we're going to switch over to, let's see, can I get this? Yes, I do. Okay, what causes moon phases? So this is from NASA. It is not to scale because the moon is not that close to the Earth. But what you will see once I start playing is the moon will swirl around the Earth. The Earth itself, you'll see spinning madly. You'll see a lighter patch, which is the Greenland covered in ice. But you'll notice that The sun is lighting everything up. The sun would be down towards the bottom. And as the animation progresses, you'll see that things will start to be lit a little bit more from the lower right rather than from lower down. So let's get at this. There we go. Spinning like a twirly jig. So yeah, the Earth spins underneath the moon. Now the moon actually does rotate once a month. You can't see that with the level of detail in this particular diagram, but you'll notice that the sun is now over towards the lower right, and it illuminates half of the moon and it illuminates half of the sun. Of the Earth, sorry. And part of what they're showing here is that the moon's orbit is not a perfect circle by any means. It's an ellipse or egg-shaped. Now, I'm going to go to the next one for a closer look, and we're going to stop the spinning. So how do we get the phases? Well, when we sort of start off the lunar month as a crescent in the sky, so this is what it would look like in the crescent. Try and ignore the fancy-dancy things around it. Just sort of concentrate on the nice crescent shape. And it is a crescent because when it is lit from that side. If we're here on this side of the Earth, just before sunset, because sunset would be here, sunrise would be here. So just at sunset, if we're there and looking towards the moon, most of what we would see would be dark, and then we would see just a little bit of the lit side here. And a crescent moon can only be seen in the evening sky as we're late afternoon, as we get here to sunset to evening. Because as the Earth rotates even more, then the Earth would actually be in the way and we wouldn't be able to see it. At first quarter phase, and you say, well, why is it called first quarter when it's clearly a half moon here? That's pretty dumb to call it a quarter. And it's like, well, you have to take the bigger perspective and think of the entire orbit as one. And so half of the orbit gets you to full moon, and a quarter of the orbit from new to here will get you to first quarter. So this is the first quarter, second quarter, third quarter, and then finally, well, the fourth quarter gets you back to new moon. So both the Earth and the moon are equally lit up, but if we are sitting on this side, right at sunset, the first quarter moon would be due south of us, and we would see it. If you can imagine yourself standing here looking towards this, half of it would be lit and the other half would be dark. So that's why we see it that way. And then moving on a little bit later, we come to what's called a gibbous moon. I've never really understood the origin of the word gibbous, but you can think of it as a sort of a fat moon. And it's called waxing at this stage when you go from a thin crescent to first quarter and into closing in towards full. That is called waxing. And when it thins, it's called waning. We'll get to that very shortly. And so here, as we hit sunset, we're on this side of the Earth here, and the Earth is turning away from the sun, which is on the right. Then the gibbous moon will be just rising partway up the eastern sky, and it'll take a little longer before it ends up across the south part of the sky. When we hit full moon, the sun would then be completely off to the right. Noon would be, if you were here, And then as the Earth turns to sunset, what ends up happening is like, now you can see the full moon just at sunset. And there's a neat little, well, it's not quite a rhyme, but a saying. It's the full moon rises at sunset and sets at sunrise. So you have to switch the words around to get the saying. But that's why when it's full moon, you can't see it during the day, because during the day, you would be on this sort of side of the Earth, the sun facing side of the Earth, and the full moon would be behind the Earth. So literally, you cannot see the full moon during the day because the Earth is in the way. But as we circle around, and here's North America here. So at midnight, we'd be on the west coast here, just about. We're completely opposite the sun, so that's midnight, and the full moon would be directly south of us from, as in if you were here and you looked south, it would be right in the southern part of the sky, and it would be completely lit. So remember that saying, full moon rises at sunset and sets at sunrise. Even I stumble over that one a little bit. And then the reverse process happens. We go from full moon, and as the moon comes around to third quarter here, because remember again, we have starts off at 0, 1 quarter, 2 quarters, 3 quarters, and 4 quarters. So it's either third quarter or last quarter, and of its circle, but we see it then as the left-hand side of the moon. Because if you were on the Earth looking here, this would be left and this would be right from an earthbound perspective. And then as it comes around to, I should say here, so when the moon is at third quarter, at sunset, you will not see it, because at sunset, you're on this side of the Earth, and again, the Earth is blocking the view. So you're looking out this way, and there's no moon to be seen until you spin around. And by the time you get to sunrise, then the last quarter moon is nicely placed due south. And then as it closes in on new moon, the crescent is waning. It's a waning crescent. It means getting thinner, or it's fading. And we can see that during the day. We will see it at sunrise, where we're just coming around here, because remember, the Earth rotates counterclockwise when seen from above. So at sunrise, we'll be able to see the crescent moon, and we'll be able to see it for a few hours until it sets, when we're then later into the afternoon. And then finally, and actually at the start as well, we're back at new moon, and this is when the moon is towards the sun. So it's visible, sorry, it's not visible, it is located in the daytime sky, because the sun is off to the right, lower right here. And we see nothing of it, because from the Earth's perspective, we're looking at the dark face of the moon. And there is no dark side of the moon, except when it is, for example, this is the dark side of the moon, the side that is facing us at new moon. But step back here, at full moon, the dark side of the moon ends up being on the other, facing away. So we prefer to use the expression dark face of the moon rather than dark side. Then what we're going to see here is what is called the lunar libration. And what ends up happening is, as the moon orbits the Earth, it's kind of a bit like a dance partner. And I'll play the animation again after it stops. But imagine you're dancing with a partner, and as you're slowly turning around, imagine you're holding hands with them, looking at them face to face, if so both of you are twirling, you only see their face, but relative to the room, like the back of their head essentially sees every part of the room. So they are turning, doing a complete circle once per month. And that's why we only see the one face of the moon and not the backside. So it happens to, it's in what we call gravitational resonance, or locked in, where the side that's facing the Earth always stays facing the Earth as it orbits. Now, what's happening here are a couple of things. There's a fair bit of interesting stuff going on. One is that the moon gets bigger and smaller. You've heard of the expression supermoon, and sometimes maybe mini moon. But what you've seen here as it's getting closer and farther, I'll start it up again, is that you've seen essentially in this animation the different sizes of the moon. When it's farther, it's smaller, and when it's closer, it's bigger. But as you'll notice, it's not a huge change. It's only a few percent, but it's noticeable once you start looking for it. That oh yeah, the moon does look a little bit bigger at that. So that's a part of what you see. And of course, you're also seeing the change in the phase. Here it is, back to a waning crescent, new moon, and then new crescent into first quarter, and into waxing gibbous and full moon again. Now, one of the things to pay attention to is, as you can see, it seems to be sort of rock and rolling a bit. It's not just a constant view. And what you should really focus on is Mare Crisium, which is right here. And we will, there we go, start it up again. And notice how, well, now it's rocking towards the limb. It's tucked right up against the limb, hardly any white space here at all. And then as our perspective changes, it seems to roll away from the limb. And the other features are all doing that as well. But Mare Crisium is the easiest one. Here it comes, and it's rolling away from the limb. We get to see some other dark seas at the top. And so this is because what ends up happening is that as the moon is orbiting the Earth, it's not doing it constantly. So sometimes her twirl relative to her turning around us is a little bit faster. And that's part of the elliptical orbit. And it's cool that this wasn't actually discovered or written down until after Galileo, and he was not the first to mention this either. It was a bit later than Galileo. But once you know to look for this, and we'll be seeing that in the upcoming month, where Mare Crisium will start tucked up against the limb and then move away, is that you can see this with the unaided eye. It's super obvious in binoculars, but even with the unaided eye, you can go, oh yeah, it's tucked right up against the limb. And then at other times, it's way very easy to see, and it's almost circular, whereas here it's sort of squashed into an ellipse. And yeah, just keep looking at the moon whenever you can, and look for this Mare Crisium on the side, and you'll notice that this sort of rock and roll motion. There we go. Yeah, and then we're into questions. So I'm going to stop sharing my screen so we can go into gallery view here. And I had seen a question that was sent to me in the chat, and the question was, can I say a few words about the Blackfoot staging area as a observing site? Certainly can. Our center has been using Blackfoot. This is an area, I'll describe it in a second here. It's to the east of the city, just past Elk Island Park. If you're familiar with the Yellowhead Highway as it goes past Elk Island Park, you'll also notice there's the Ukrainian Village Heritage Center there. And so it's just past the Ukrainian village at the top of the hill. You turn right down a range road south, and you just go to the end. And so essentially what a staging area is, it's a public, well, not park, but area that's got a very large open parking lot. It's plowed in the winter. So it's very convenient for us to bring our telescopes and plonk them down. It's like it's not as big as a Walmart parking area, but it's getting there in terms of size. So it's a significantly large area. It's surrounded by trees, which is really good in winter because, as you know, even a slight breeze at -10, it adds a bit of sharpness to it. It's like, eesh, it's tough. And so with the trees that surround the Blackfoot staging area, it cuts out those light breezes really well. If the wind is howling, it's going to be blustery. It's not as bad as being completely exposed. But, and so we've been using the Blackfoot staging area as an observing site for easily 20 years since when I got here in the 90s. We had just shifted from the Sherwood Park side of Elk Island Park. There's another Blackfoot staging area there too. Unfortunately, it's the same, sort of the same name, but there's Waskahegan Blackfoot, and then there's just Blackfoot, which is the one on the east side of the park. And so you just drive up. You can. It's sort of encouraged that you arrive earlier in the evening while there's still light, so you can just sort of drive up and park and not disturb other people with your car headlights. It's very disturbing to have someone drive in with full headlights after you've been completely dark and hafted for a while. But yeah, drive in and then set up your telescope, whether it's visual or imaging for doing astro shots. I've seen it at sort of maximum capacity. It's probably like 30 cars, if not even a little bit more. It's pretty neat, but you sort of get into the habit of pointing your car away or towards the exit. So at the end of the night, you can just sort of drive out with a minimum of effort and a minimum of annoyance of other people. The really nice thing about Blackfoot is because it's a cul-de-sac where there's no exit, you just drive to the back end of it, south end, and that's it. So there's really no through traffic. Every now and then you get a car or a truck driving in to have a drink or use the campfire there in the back. But it's generally not used at night. And so it's a good place, and because it's off-road, it's very sort of safe. You don't have to worry about cars whizzing by. And the nice thing about it is that it's that sweet spot between reasonably dark and reasonably close to the city. So there are darker places, which Black Nugget Lake will be one of them. It's another sort of 10, 12 minutes farther from the city than Blackfoot is. And so you get darker skies the farther you go. The really nice thing about Blackfoot, like I said, it's got this enclosed, it's not exposed to the wind, and some of the places I go to, it's a township road where the combine goes into the farming field, and I just kind of pull over and set up. But there's only really space for 2 or 3 people at those places. The nice thing about Blackfoot, again, is you're also, you feel secure if there's 2, 3, 4, 5 other cars there and people with telescopes, then you really don't have to worry about some Yahoo driving in and sort of, oh, there's this lone individual there, we can go and bug them. When there's a whole bunch of cars there, yeah, we usually see a car come in just like, oh, now they'll turn around and go out. So we're really left in peace at Blackfoot. It's losing its darkness as Sherwood Park and the city have grown and grown and grown. More street lights, more houses with lights on. The skies are getting a little grayer there, but they're still quite good for that. And there's really no better place to hold a whole bunch of people. It's a pity that we're losing some of the night sky, but it's still far, even as is, it's far better than a 1 hour sort of a 90-minute drive from Montreal, which is what I grew up with in my younger teen and young adult days. I used to drive 90 minutes from Montreal to get to a dark sky site, and it's not as dark as Blackfoot is. So yeah, Blackfoot's a real good place for that. So long explanation.
Alistair, Peggy asks, where is exactly NGC 1981 in relation to Orion, the Orion Nebula? So I actually have added another slide to the presentation with a little bit more of a, so if you can please bring the presentation, I put it at the very end. I don't know if you can.
Yep, give me a sec here.
Yes, sure, for sure.
The screen is always 2 or 3 seconds behind. It's just like, press next page, waiting.
Yeah, but thank you for asking, Peggy, because it's true that I was not very clear in what is exactly this NGC. It's a little star cluster. So it's just a group of stars. It's not a nebula or anything like that. It's just a group of stars that have kind of the shape of a little creature, like a little 4-legged creature. And it's just on top of the 3 stars that make the soar of the Orion Nebula, or sorry, the soar of the Orion constellation.
And very easy to see from the suburbs with a small telescope because they're just straight individual stars. It punches through the light pollution reasonably well. And so it's actually pretty easy to go beyond some of the well-known catalogs, like the Messier one with all the galaxies and gas clouds, and it has some star clusters too. But the next catalog, New General Catalog, that's what the NGC stands for. Yes, it contains thousands of super faint objects, but it also contains hundreds of quite bright and quite easy ones. Some of these objects were originally not recognized as an actual, for example, in this case, a star cluster, where some of the earlier observers might say, oh yeah, it's just a few stars. And then as astronomers paid a little bit more attention, so like, wait a minute, that's actually a group, and they're actually near each other in space.
Do you want me to share it, Alistair, or do you?
Sure.
Oh, okay.
Oh, do you have a different, do you have a closer up version of it?
If I find Safari somehow, am I allowed to share things?
You should be able to. I might have to give you permission here. Let me just see.
Hold Shift to select because it shows like
Wait a
so
minute.
like a
Had I actually shared my screen in that little blob?
No, you didn't share the screen.
I
So
didn't share
that's
my
at least
screen.
I'm not seeing it, so that's why
Okay.
I'm
Sorry. Let me. Okay, you should be seeing this now.
okay. Yeah.
Sorry about that.
Mm-hmm.
Well, Jeff, you're in good company. Every now and then I make mistakes too. There we go.
So do you have the mouse now, Alistair?
Oh,
so
okay.
if you wanna again explain, we have the 3 stars that make the belt of Orion, and then as you go down, you're gonna see the sword of Orion, which looks 3 stars, and the middle one is fuzzy because that's basically where the nebulosity is. But then on top of that, you see it circle in this image is NGC 1981. It's just a group of stars over there. And I hope, Peggy, that answers your question.
Yeah, there's a lot of objects out there that have common names that remind people of things, like the famous Horsehead Nebula is right actually here. Now that is a very difficult object. Comes out very nicely in pictures, but visually is very difficult. But yeah, there's all sorts of things like sailboat clusters, and a lot of star clusters are difficult to describe because they're mostly roundish with a lot of points. But every now and then, some of the star patterns evoke some earthbound thing. Because there's an owl cluster, an owl nebula as well.
And I have to say thank you to Jacqueline, because exactly I wanted to mention that an Ardabak looks like an anteater, but somehow the word was not coming to my head. That's why I said it looked more like a weasel or like a raccoon, but it looks like an anteater, like a 4-legged creature. And so if you look at that constellation, that asterism NGC 1981, it has the shape of a 4-legged creature. Yeah.
Yeah, and actually the nebula here, just north of the Orion Nebula, is sometimes called the Running Chicken Nebula, which sort of evokes something interesting in your head, but you sort of look at it and go, I don't see no running chicken in that blob. But it can be fun. Stop my sharing. We can get back here.
All right, so I don't think we have any more questions.
Okay, then. Well, just thank you very much for joining us, and we will do this again next month. And of course,
actually, sorry, Alistair, that I interrupt you. Linda is asking if you can read. There are a few staging areas for the Blackfoot. Are you referring to the one of the Yellowhead, south of Range Road 210, or farther east?
I don't know. Let me just call up. Oh, get out of here. Well, get my Google Map. Oh, I'm not sharing my screen again, right?
That's correct. Yeah.
Okay. Let me with you in a second here. I'm just calling up Google Maps.
Is the one of the Yellowhead of Highway 16 after you pass the Ukrainian village sign. So you pass Elk Island Park, and just as you finish Elk Island Park, there is a sign that says 1 kilometer to Ukrainian village, or I don't know exactly what it says. And then you turn off just after the sign, and then that's what it is.
Yeah, there's there's a handful of staging areas. It's also used in February for the Birkebeiner cross-country ski
Alistair, I just looked it
competition.
up on the back of Stardust. It's Range Road 195.
Ah, okay. I'll just show it here. There we go. So there's Edmonton Sherwood Park, and it's literally as you exit Elk Island Park. Not that there's a big sign. It's the very first exit past the Ukrainian village. Somewhere in here it should. Switch over there. Just, switch over to the satellite view. So here's the Ukrainian village coming up in a second here. There we go. This would be the exit for the Ukrainian village. And then this is going up a hill right here. And it's literally, there's the next road. And we're still in, there are a lot of sort of private houses here and there. But as you're going down this dirt road, you really can't see much. You just sort of keep going south, and here we are. All of a sudden, it's boom. Here's the end, and you can see the size of the parking lot. You know, even from this scale. These are well, sort of lakes, bogs. There's beavers here, so every now and then you can get quite the scare when. In the dead of winter when it's really quiet and the beaver fells a large tree. It's quite startling. But yeah, you drive in here, and although you can turn into the main parking lot, what we always suggest is you drive around the back side. You sort of let your car idle a bit, but you turn off the lights. And you let yourself get dark adapted, and you walk in, and you see where other people have parked their cars and their instruments, and everybody is more than happy to walk you in. If you dare to turn your car headlights off, someone will escort you in with red lights, and you just follow the red lights to a point where you can park, and then when you time to drive out, you just drive away from where most people are settled. But here's the shack. There's a bathroom there as well, which is really nice. If when nature calls, you can actually use a bathroom. Yeah, there's a shack here, and then campfire site is just sort of behind here. So even if someone's got a campfire on, usually the trees are just lit up. That's so that's that one. So the other Blackfoot was on the east side of the park. Just scroll out here, so it's somewhere in here. But it just ended up being too close to the city, and slow bit by bit, but the light pollution is just getting worse. But now notice here when I zoomed out, so Blackfoot being down this corner here somewhere, we're also not that far from Islet Lake, which is one of these guys in here somewhere. Which is another staging area with a large parking lot. That's takes a little longer to get there because you have to spend more time on the smaller roads getting in.
Okay, so thank you, Alistair. That's a very good answer. So I think we don't have any more questions for tonight. So we can reconvene again in 4 weeks, the fourth Wednesday of March.
Yeah, and just remember next week, 1 week from now, Jeff Robertson here will be talking about what's up in the March sky, a little bit more on planets. Venus is out there in the morning, it's very bright. So,
Yep.
Don't hesitate to step outside and look up. Okay, have a great week, everyone.
Bye. Thank
Sure.
you.
Bye.
Bye.